I know this, at least for me, 3:30 in the afternoon is about nap time. So I'll try to keep my spirits high and hopefully keep you at least informed, if not entertained. So thanks for the introduction, Nick. That was very nice of you. I run a studio in Seattle called Absolute Hero, and we started this studio about 2 years ago to focus on building casual games using HTML5. And I'm going to talk a little bit about that decision and why we made that decision and some of the things we've learned over the last 2 years in developing games with HTML5. Before I do that, I just wanted to, oh, that's a little blurry, isn't it? Just wanted to show a few of the games that we've developed. We work primarily on work for hire for studios that either have existing titles that they want ported to HTML5 or new titles that they want developed in HTML5. We did a series of games, the Playdate series of kids games for Spill that are pet training and pet care games. We've built word games. S'more Words is a word scramble type game. Flackboy was a port from a Flash game. It's a rather violent crash test dummy physics simulation game. So you can do physics-based games in HTML5. SugarLink is a Mahjong Link style game with a building mechanic that allows you to build desserts. Match Bingo is sort of a cross between a Mahjong and Bingo. Lovelink World is another game we built for Spill. It's a larger social saga-style game with a puzzle mechanic and a map scene progression and power-ups and things like that. Text Twist is a port of an old classic Gamehouse game that we built for Gamehouse in HTML5. And Little Shop of Treasures, we built a series of 3 Little Shop of Treasures games. Those are hidden object games from Gamehouse that we ported to HTML5 for them. And then Samurai is our own IP. It's another puzzle saga-style game with a map progression. We launched it about 6 weeks ago on Facebook, and we're going to be launching it on mobile soon. And I'll show you a demo of that game that kind of shows some of the things we've been able to do with HTML5 towards the end of this talk. So, why am I here? I'm not here to convince you to build games in HTML5. Sorry, Nick. In fact, if anything, if I convince you not to build games in HTML5, I would consider this talk successful. I think it's important. I'm going to talk about some of the things we've learned, some of the perils and pitfalls of HTML5. But I think it's important, if you're interested in HTML5 development, to ask yourself why. Why do you want to build a game in HTML5? Or maybe even more importantly, who are you building a game for? Because you really need to understand who your audience is and where they're playing games. So for instance, if your audience plays games on mobile devices, and only mobile devices, HTML5 is probably not a good choice for you. There are much better development systems to build mobile games, native mobile games, than HTML5. So know who your audience is, know why you're building the game, and factor that in when choosing a technology. If you do decide to use HTML5 to build games, you should understand that the tools are not as mature as alternative game development environments, and that there's massive fragmentation across browsers, which is something that you're going to have to deal with. So, without further ado, let's get into how to make games using HTML5. I've created a sort of a top 10 list. For one, I like top 10 lists, and it's an easy way to organize a bunch of otherwise disorganized ideas. So, as I mentioned, we've spent about 2 years building games in HTML5. When we started, I didn't know much JavaScript. I was a C and C++ developer, and I had done a little bit of dabbling in the web. If you've done web development, you've likely experienced JavaScript. If you're like me, most of the JavaScript you experienced was bad and usually written to do something quick and dirty on a web page. If you're a web developer and you're well-versed in JavaScript, this talk is really oriented towards game developers. So there may be things that you already know that you find boring, and you might find some of this offensive. Fair warning. So my first tip in using HTML5 to build games is don't use HTML. HTML5 is a term that the industry has settled on for a group of technologies: HTML, CSS, and JavaScript. And HTML is a great technology for doing document structuring. And CSS is a great tool for doing document styling. Neither of those things are things that we typically do in games. So we don't use HTML except to provide a framework to draw a box on the screen that we can render graphics into. I don't know who invented CSS, but I can't wrap my head around the syntax, and we don't use that at all. What we do use is JavaScript. So when we talk about building HTML5 games, what we really mean is that we're building JavaScript games. JavaScript has been around for 20 years coming up in September. It was invented in Netscape. I think it was famously written in a week, and it's evolved a lot since then. When we started our studio, I didn't really know much about JavaScript, and I knew just enough to be dangerous, but I had a lot to learn. But JavaScript does have some good attributes. It has some problems as well, and those have been documented elsewhere. I'm not going to talk too much about that, but I'll talk about some of the benefits of using JavaScript as a development environment. This is going to get a little bit technical, so I apologize in advance if this information isn't relevant. But, JavaScript is what's called a loosely typed language. I used to work with a developer back in college, a guy who was sort of locally famous back then. It was sort of easy to be a famous developer back then. And he was a sort of a curmudgeon type character, and he used to say that strongly typed languages are for people with weak minds. And I think what he meant by that is when you use a loosely typed language, you need to have a lot more discipline in terms of how you use the language, because you don't have the strong typing of the language to help you out. Loose typing, strong typing allows the compiler to do lots of optimization and error checking for you, which is great. But loose typing is more flexible in terms of your object and class definition, and it allows you really easy refactoring even at later stages of the development cycle. Another advantage of JavaScript is what's called the JavaScript object literal notation. Object literal notation allows you to create an object just by listing out the names and the values of the elements of an object. And this can be really useful, especially in early prototyping stages of development. JavaScript is what's called a JIT compiled language, a just-in-time compiled language, and it runs in every modern web browser. I would guess there are more computing devices that run JavaScript than any other high-level language. The fact that it's JIT compiled and it runs in web browser means that the code development and test cycle is very rapid. You can make a change and reload your browser or have it reload automatically and see the effects of that change immediately. There's no compilation. There's no waiting between the time you enter code and the time you can test it. It's almost immediate. That allows you to iterate very rapidly on features. JavaScript has a corollary format called JavaScript object notation that's inspired by JavaScript's syntax, and it's a great format for creating configuration files that you use within your game. And it's simple enough that you can even take non-developers, even non-technical people, and have them change attributes within it and allow them to manipulate elements of your game. So for instance, we built a layout engine that allows the UI to be described using JavaScript object notation in the game. And so things like dialog boxes can be styled, text can be moved around, sprites can be moved around. And we have our artists do all the direct design of the dialog box directly within the game. They can change the JSON, reload the game, and modify it to their heart's content. That makes them very happy because they tend to be much more particular about how things look than the development team. If you're interested in learning more about JavaScript, the book that I learned from is called JavaScript: The Good Parts by Douglas Crockford. It's a thin book, but it does tell you the right and wrong things to do with JavaScript. Okay, tip number 9. Is anybody falling asleep yet? I realize this is deeply technical, so I'm going to go quickly through some of this stuff. With JavaScript, there's not a pre-existing IDE. There's not one way to do things. You need to make some decisions about how to organize your code, and you need to stay disciplined about doing that. Otherwise, you're going to create a mess. The games that we build have a lot of code in them. It's not like writing a simple web page with a couple of functions. I mean, we're talking thousands and thousands of lines of code, hundreds of classes. And so you need a way to organize all this, and there are multiple ways of doing it. But the way that we've decided to do it is using what's called a module pattern and a module loader. And what that means is that it's just a way of encapsulating code definitions in a way that allows you to manage dependencies and keep things that are related together and things that aren't related separate. And then we use a tool that comes with Require, or this part of the Require package called RJS. And what we can do with that is each class that we have is kept in a separate file during development, and when we're debugging, we can access individual files and do source level debugging on individual files. But when we go to deploy, we run RJS over the collection of files, and they get packaged all together into a single file. Then we run some other obfuscation and minification tools over it, and that's our deployment. That's our deployment package. So you need something like this. You don't necessarily need to use Require, but you need some system for organizing your code. This is an example of a it's hard to read. Number 8, use a package manager for dependency management. So a lot of these tools, if you're a web developer, you'll notice we've borrowed a lot of tools from web development. And that's because those are the most mature tools for developing in JavaScript. They're different from the tools that you would normally use as a game developer, although I'll get into some of those in a little bit. Bower is a tool that allows you to manage package dependencies. So we use a lot of open source software, a lot of open source packages, and with Bower, we can just list the name or the location of the package on the internet and put it in a configuration file and type one command and have all those packages downloaded and installed on a developer's machine and ready to use with the game. Number 7, use a JavaScript task runner to automate common operations. So back when I started doing development, we used a tool called Make and Shell Scripts. And Make, I don't know if anybody here has been doing development for a long time, but it was great. I mean, Make allowed us to describe how we wanted, the order we wanted things built in, how we wanted other things that we wanted run across our code. You code it all up in a Make file, and you just type a command, and it all happens for you. Well, there are similar tools for JavaScript. One's called Grunt and one's called Gulp, and they're both similar, but similar in substance but different in style. And they both allow you to automate common tasks. And one great thing is there are a bunch of existing plugins for them that you can download to use in your development. And when I say automate common tasks, I mean things like building a release package. We use it to create a tarball for delivery to a client, or we use it to optimize a set of images or transcode a set of audio files. It's just a scripting tool, but it allows you to define exactly what you want to do and run a command in the command line and have it all done for you. All right, I still have you? Number 6, use a code editor with integrated syntax highlighting and linter. JavaScript doesn't have a compiler. Compilers do a lot of things, but one of the things they do is catch syntax errors. And they help developers, help keep developers from making silly mistakes. You need to use other tools with JavaScript to help you do that. And one of these tools you can use is syntax highlighting and interactive linting. I use an editor called IntelliJ, but there are a number of other editors that you can use. They'll give you warnings when your code is either wrong or non-standard in some way. And the warnings are usually in the form of some kind of highlighting of the text of your code. Pay attention to these things. I've found more often than not, even if it looks innocuous, fixing it saves me a headache down the road. All right, now we're going to get into more of the game development stuff. Those were tools and things that help you use JavaScript. These are more specific to HTML5 games. So this is a messy slide and pretty ugly slide, and I think it accurately reflects the state of HTML5 audio. Because audio codecs are subject to different licensing, different browser manufacturers have support for different codecs. And that means that if you want to be able to play audio in your game across different browsers, you need to support different audio formats and different file formats. So every game we do, we encode audio in OGG Vorbis, MP3, and AAC M4A. And that seems to cover everything that we've needed to cover to date. In addition to multiple codecs, you have to support multiple audio playback methods. The newest audio API in HTML5 is called the Web Audio API, and it's great. It does everything we need it to, and it's got good support among most modern browsers. However, if you want to support legacy browsers, older mobile devices, you need to look at other methods. So there's something called the HTML5 audio tag, which was the method used primarily before the Web Audio API. In some cases, if you have Flash available, you can get away with what's called a Swift bridge, where you're actually loading an invisible Swift file to play audio through. If you're wrapping for native distribution in Cordova, sometimes you need to use the Cordova Media APIs. And we've got a library which figures out at runtime which audio capabilities are supported and chooses the most appropriate one for a device. Number 4, use texture atlases. I think if you've been doing game development for any amount of time, you're familiar with the texture atlas technique, but if you're coming from web development, you may not be. Texture atlases combine multiple images or multiple sprites into a single image, and they allow for efficient packing and efficient rendering of sprites to the screen. It's maybe even more important in web development because every time you or you need to load an image, you need to make a request across the network. So you want to minimize the number of network requests you're making. So by packaging multiple assets into a single image, you can do that. The way they work is, I'll show you a picture of some. These are some of the texture atlases from some of our games. The way they work is we use this tool, Texture Packer, to generate these. It's a great tool. So the texture packer takes all these, packs them optimally within a whatever defined size you want to, and then it generates a meta file that tells the game the position and other attributes of the sprites within the larger image. And then we just use a game engine which knows how to read these and index into those and blit them to the screen. Number 3, have a plan to deal with multiple resolutions and aspect ratios. You're writing a game in HTML5, which means it can run anywhere HTML5 works, which means any modern web browser, which means any desktop PC, any laptop, any phone, any tablet. Unfortunately, the aspect ratios, the resolutions, the orientations of all these screens vary dramatically, and you need to plan for that. If you decide you want to build a game and it's just going to, or you just choose, for instance, one resolution for your assets, there's no way you're going to cover every possible device. It's either going to, the assets are going to be either scaled up and be too blurry on some devices, or scaled down and you're wasting a bunch of space and CPU or GPU copying those images on smaller devices. So in addition to multiple resolutions, you need to be able to support rotating a device. In a mobile browser, there's no way to lock the orientation. So your game needs to do something when the device rotates. It doesn't necessarily need to support gameplay in that mode, but you need to handle it in some way. We support, in terms of resolutions, we support a flexible system that allows us to generate. We have what we call resolution classes, and we generate all of our image assets at multiple resolution classes, and those are packaged with the game. And then at runtime, our game library determines what the optimal assets are to deliver to the device, and only those assets are delivered over the network. And we use Grunt to automate that process. Number 2, master different animation methods. There are a number of ways to animate in HTML5, and not every method is appropriate for every type of animation. Some methods are more optimal than others depending on what you want to do. We use 3 types of animation primarily. We use skeletal animation. We use a tool called Spine to generate skeletal animations, and what that is a series of body parts, if you will, that are linked together in some well-defined way, and then animations are defined by an artist, and then the programmer can trigger those animations at certain times in the game. We also use what are called sprite sheet animations. These are pretty common. It's just a series of images, like a movie, that you're playing in sequence. And we also use particle effects. We use a particle engine called an HTML or a JavaScript particle engine called Proton, and we have particles, and you define how you want the particles to act, and you can do things like simulate fire or explosions or fireworks and things like that. We're at number 1. Use WebGL where you can, but fall back gracefully. Now, we make 2D games. WebGL is primarily thought of as a 3D technology, or GL is. But WebGL also gives you access to hardware-assisted rendering. And so it can be very advantageous to use for 2D games. When we pack our images with Texture Packer, we pack them in such a way that they can be loaded into GPU memory and blitted rapidly to the screen without involving the CPU. Even better than using WebGL directly is to use an engine or framework that supports it. We use a great rendering framework called Pixie.js. There's also a game engine called Phaser that does a lot more than just rendering. It does a lot of things that we've built up over time ourselves, like physics and particle effects and loading and that kind of thing. And it's also built on top of Pixie. I think if I were starting out again today, I'd probably take a strong look at Phaser to build my games on. And of course, I'm a developer, so we have number 0, which is actually 11. But this is an important point. And just because your game runs in a web browser on your desktop does not mean it's going to run in a web browser on a mobile device. It does not mean that it's going, just because it runs in Chrome doesn't mean it's going to run in IE or Safari or Opera or Firefox. You need to make sure you're testing across platforms, across browsers during development. Especially mobile devices have all sorts of idiosyncrasies, differences in APIs, differences in form factor, differences in performance. You need to constantly test on these devices. If you're serious about building HTML5 games and you want them to run across devices, you need to have a library of devices available. Go out and buy them. They cost a few $100 each. I'm to the point where I don't even want to see a new phone anymore because we've got so many devices. But you need to test across these devices, and you'll find some that are very problematic and will cause you a lot of headaches throughout your work. But by making your game work on those problematic devices, it will end up working better in other places as well. So do I have time to do a demo, Nick?
You have time for a demo, yeah.
Okay. I'm going to do a demo of our game Samurai. Oh, it's up there. Oh no, that's my slide deck. Let's see. Make sure I'm still on the network here. Wow, this is really low resolution. I can't even get to the, oh, there it is. Let's see. All right. So this game is on Facebook now. Sorry you can't hear the sound, but, and it's built in HTML5. Using all the techniques that I just described. It's a saga-style game with a map scene. I'm going to go to one of the easier levels so I don't embarrass myself. It's a pretty hard game. So we call this a side-scrolling block mover. The object of the game is to get your character Sam from one side of the screen to the other by manipulating these blocks on the screen. So I can click on groups of light-colored blocks. It's a standard, fairly standard mechanic, but the side-scrolling and the moving of the character adds a new twist to it, and it makes for lots of interesting puzzles. The other thing you'll notice is blocks at certain times will slide to the right, which can shift the board in unpredictable ways. So you can see some particle effects here when the blocks are destroyed. When the character is moving, that's done with skeletal animation. If you notice on the loading screen, there was a little character running from the side. That's using sprite sheet animation. See if I can this should be a relatively short level. Those throwing stars were also done with sprite sheet animations. So that's Sam. And let me go. You know what? I'll just leave this up on the screen because I don't have any more slides left, and I'll take any questions.
Okay. Well, time for, my first question is: I mean, you've given us how to run the obstacle course, which is awesome. But why? What motivated you to start down this path? Was there some reason we could do HTML5 that nobody else is doing, so we'll become experts at it, or there was some market that you couldn't do through Flash or Unity or something? Why? What persuaded you to go down this path?
Well, we were looking to start a new game company, but we were afraid, frankly, of the realities of the market in terms of competing on Facebook or competing in mobile. And so we were looking for a niche. A friend of mine showed me a HTML5 game. It was a bubble shooter. And it was done so poorly it actually made me angry. And I told him, I think we can do a better job. Why don't you give me a shot? So I called up an artist friend of mine, and we made him a game, and they loved it. And we actually started the company around that. We did a contract for 10 more games after that.
Okay, well, unfortunately we've run out of time for questions, but you'll be around, you can drink beer with everybody later on?
Yeah, and we've got a booth over in the expo, and we're showing off this game, and happy to talk or answer any more questions about HTML5 development over there as well.
Okay, thank you, Craig. That's awesome.
Yep. Thanks.